Alright, good to know. Alright, we'll go over robot design. So, we'll prototype based off of 2022. And you will... This. So we've got this year's game. Wait, no. This is 2023. It's 2023 this year, right? Yeah, it's this year. Okay. That's an odd name. Alright, there we go. I got it. Alright, so we'll prototype based off of this game. It's a pretty simple one. So, first, make a document. Yeah, there we go. So we've got a half inch, let's see, make a sketch. So we'll say, okay, I want my chassis to be, just do like a quick design. I want my chassis to be, how big was our chassis that year? Let me check. Give me a moment, I'm gonna check how big our chassis was that year. 29 inches. So 29 inches. So that was our chassis. And then we have a ball this big. And we want to intake it. So what we did was we had over here. We had a plexiglass piece that attached right here. And then, so it would attach right there and then stick up out of our chassis and then go down a bit. Let's see. It was more like this. Our bumpers would stick out a little bit. And so what we did was we had a, up that far. Just about like. If you got any questions, you can ask them like via, if you're still not caught up on the whole like actually making the 3D models and sketches bit of it, you can always ask questions about it. So we had to go like, I'm using a trackpad for my other documents, so it's taking a while to navigate through. So it went out like this. Shaft right there. And it would go hex shift. This. We had a hex shift right here. So this is roughly what our robot looked like last year. And we had a hex shaft right here as well. So this was a hex shaft. Or not. Yeah, last year. So we had, I think, yeah, half-inch hex shaft. So we had a half-inch hex shaft here, I think. No, not right there. Well, no, yeah, no, not right there. It was, in fact, right here. Okay, so how it worked was the ball would come up, and this intake, this whole intake right here could actuate on this joint right here, which was connected via a side plate. So we had a ball bearing, I think, or something connecting that, slotting that in, and it would slot onto the side of an internal bar, and then so then that would lift up, it would go in, and it would, there would be a pulley right, there's a motor right here, 2 hex shafts right here, and it would spin this as well. So then it would go onto a conveyor, it would be compression, and then it would fire out. So that's how that roughly that worked last year. So we'll go ahead and make like the bars. We'll go ahead and make the chassis. We used extrusion for our bars, 1x2 inch extrusion. Yeah, 1x2 extrusion. So we'll go ahead and make that. So our chassis was 29x29. So that means that if you include the swerve modules, okay, so the 29x29, so they were about, we'll make 2 rectangles here. And then we'll make a distance between, the distance between this and this is 29. I'm going to create a construction line between here and here by pressing Q. And then actually, we want this to be midpoint. So this and this should have a midpoint constraint. Ta-da. Alright, so then we want to offset these. Ah, shoot, I messed up. We want to offset that. Do not want to offset that. We want to offset that by 0.1. That's how thick our extrusion bar was. Same thing here. Then we will take this face right here, this face right here. Our bar was 25 inches long. If you include the swerve modules, that's how long it has to be for the chassis. We had swerve X modules, so that's why it's not 29. It's just 25. So we'll extrude these two, and then our so it was a rectangular or a square chassis, so roughly the same on both sides. Give me a second, I gotta fix my. So we can just duplicate these once we extrude them. So our chassis looked about like. Let me change the colors because colors are the most important thing. Colors are very important. Oh, look at that. Look at that gray. Everybody loves gray. Any questions? No questions. We will insert two of those. We will fix this. And fix this. Actually, undo that. Just to make it a bit more proper, I'll have this extrusion be symmetric. Ta-da. Okay, now we can insert these two things. I will fix this back. Shoot. I'll have these two be fixed. Means they're going to stay still. Now we're going to go to CAD, insert our swerve modules. We had swerve X. We'd had 4 of these. We wait a little bit for it to insert. Okay. Now we had holes on these bars for the swerve modules. Just so happen to be exactly in the center. They were positioned a bit funny. Let me go to that part studio. Wait. Okay, that's a really odd diameter for the holes. These holes have a diameter of 0.159, and the it is really odd. I'm gonna have to double check this. Give me a second. I think we used a different attachment mechanism than normally. No, we used the Mark IV swerve modules. Okay, that's where I'm going wrong. So we did not use the Swerve X. It was a lie. I've lied to you all. We used the Mark IV. And the holes are 201. That's not very much better. I'm going to have to see about this. Okay, apparently the holes for the mounting mechanism that we had last year was just larger than these holes, but we're not going to design it like that. What we're instead going to do so we need these to attach on the corners. So that should attach. About right there. I don't know quite how far. As long as it's even. Okay, we're just going to experiment. We're going to do a little bit of a trial by fire. So we're just going to put the holes here. And the distance between here was 0.5. So we drilled these holes out. The distance between these holes is 1 inch. To make it -1, make it go the other way. We want like, I don't know, 29, 25 of these. And we mirror that. Alright, we'll just select all that. That'll work. Check mark. And it should extrude the faces of sketch 2. Yeah, it should go through. But it's not. Wonder why not. Wonder what I did wrong. Should go through all. I don't know. We'll just use that one bar. This one extruded successfully. So, but look at that. Isn't that beautiful? This one can go away. So can that one. This one did it right. This one's fixed. All right. So now we can mate, fasten, and then we can select the bottom of this word module with the top of this. That is mounted incorrectly. Yeah, you betcha. This is why we design things before we build them, ladies and gentlemen. I'm gonna slap that onto now I'm doing something wrong. I'll tell you that much. Should be that corner, right? I've done something wrong here. Give me a second. Let me move that over. Fasten, mate. Okay, got that. We're gonna select the top of this with the bottom of this. Boom, look at that. First try. Oh yeah. We're going to insert a few of these more parts. We're going to put in... Is this the right part? No, it is not. This is the right part. It is... We're going to fasten. Bottom of this. To the top. This. We're going to flip it and rotate it. Check mark. Now I'm starting to wonder if these wheels have room. They ought to have room. This is how we designed our chassis. Yeah, they've got room. They can spin. Just barely, but you know, that's why we design our parts. Now this Now we do another one. So we'll fasten the corner of this to the fourth one on this. Rotate it a bit. Check mark. Fasten this to that. Check mark. Gives you a little dopamine hit every time you hit the check mark. Do we have anybody asking any questions? Why don't you sketch the drivetrain rails from the top down? Tube converter can save a lot of time here. So, tube converter, if you're referring to the feature, that would speed up a lot of time. The goal of this is to teach modeling, so you won't find me taking too many quick shortcuts, just so I do a little bit more hard modeling while I'm going along. From the top down, what I could have done, since the chassis is square, I just made one part. From the top down, what I could have done, what this guy Bishy Dill's referring to, is I could have sketched just this right here. It would just been like, here's a square, here's a square, here's a square. I could have extruded them up 2 inches, and then I could have shelled each one of those. That would have been faster, but since I'm only doing one bar, I just made the one. And there's a feature script to make this tube for you, or you can just import the tube from something, but I just chose to do it that way. I thought it'd be a little bit more modeling education. But yeah, good feedback. I like this. People asking questions like this is good for the teaching experience. Helps me refine the classes further. Anyway, we'll go ahead and finish fastening that out. I don't know, through these. Apparently there's 2 of these in here. Let's see. Fasten that on. Check mark. Ta-da. Alright, so now we should have our chassis. Okay, so like, what you could do is, in your build season, go ahead and give this to build. Be like, okay, this is our chassis, we're going to design everything around it. We'll design everything around these holes, we'll replace the bars if we have to. And so once you give this to build, they can go ahead and start working on the chassis. Now, once they have this chassis, while you're designing the rest of the things, you can, programming can go ahead and take this chassis and start working with it. And update their libraries, smack a Robo Rio on the side, just put a few electronics on, duct tape and zip ties. And 'cause you don't need a whole robot to practice most of your driving or programming stuff. with the chassis. And it's a good opportunity to motivate your programmers to go ahead and update all their libraries and make sure everything's working properly on their code, on their like software side. Works pretty well. So now that we have this, we're gonna go ahead and design kind of the rest of the. So what we did was we had 2 bars that come from here to here and here to here. They're like this. This is the front, so that means we had a bar right here and a bar right here. And then we had a side plate attached to it. And then out came our intake. That's kind of how our robot looked like. Ah, shoot. So we had, let me go ahead and check this. That's what we did. And what we did was these 2 bars had a hole right here that had belts on it. And these only attached to this side of the bar. The other side of the bar was reserved for the intake. That's what we actuated around it. And then we had pneumatics right here that would pull the intake back and forth. So we'll go ahead and design that. So distance between this and this, 26.8 inches. Bit odd. Now, I think what this guy's referring to is the sketching from the top down. Now, we'll just do 1 bar. What I could do is say, okay, here's my bar. It's going to be by 2. Extrude this up 2 inches. Oh, wait, no, I want this to be by 1. And then touch on that. What I can do is shell this that way. Shell thickness 0.1. And then extrude that face. And now I've got a bar. Pretty cool. So that's what he was referring to. I just wanted to do it because, or at least I think that's what this guy's referring to. Those cars were conveniently placed in a really weird spot, 14 inches away from each other. So what we'll do is use the power of magic . Power of magic does not want to work. Internet is being a bit funny. We will fasten. This to that. Boom. Then fasten it to the middle there. And then we will offset it. Cool. To X by 7 inches. And then do the same thing for this. Fasten. You can hold shift to make sure that you're selecting the right thing in fasten. Make connectors is what I mean. Like if I hold, like if I mouse over this, you know, it'll switch to this. But if I mouse over here and then hold shift, it won't select any of that. But then if I let go of shift, it'll select all this. And offset it. Make it a 7. Boom. In about an hour, I have, now, this is teaching, so it would take you less time if you were sitting down in the corner of a room all alone and silent. I think this tube has been shelled the wrong way. I think I did it wrong. It is definitely done wrong. No. This tube is done wrong. Yeah, this tube is 0.1 inches too big. That's because when I go to my part studio here, what I did was this right here should be offset by 0.1. Actually, it should be offset by the other way. Isn't that crazy? Now, this extrude is acting funny. So go ahead and fix that. I'm gonna have it be this. And that. Now, the sketch needs to go, bit odd. Gotta make it -1. Make another one of these. 6. Alright, hopefully that the model doesn't break. Uh-oh. Oopsie daisy. I did oopsie. I mean, you know, it's mostly accurate. Yeah, that's a bit. I goofed. I did a goof. I apologize. What we'll do is we'll just drag these and it's fixed. Ah, brother. That's a big goof right there. I'm gonna be real with you. That isn't. That's no small mistake. Okay. I don't think we quite have the time to fix this, but what we'll do is we'll just drag these kind of roughly where they need to go. Say it's good enough for government work. Andy, go look at him. He's beautiful. I mean, you know, basically the same. Anyway, that's wrong. Alright, I'm gonna have to fix this. I can't let this slide. What is happening to the spar? It is not working. This is set to remove through all. I'm gonna set that up to face. It is not removing what I want it to remove. blind 2. Symmetric 40. I don't know why it is doing that. Merge with all. Okay, now it's working. Merge with all was the big problem there. Anybody say anything? No, no questions. Anyway, fasten. Go ahead and this needs to hide. Grab that. Unhide that. No, this is fixed, so we will do it off of this. Offset 7. -7. Whoa, magic. Oh my gosh. That's gotta be wrong, right? Can't be right. No, that's right. I just didn't make everything up properly yet. Okay, we'll go ahead and fasten everything that needs fastened. Fasten. Ba-ba-ba-ba. We will attach this to this. There's a hole missing there. I will fix that later. We'll attach. I've made too many blunders to be considered a competent CAD teacher by now. I will become the face of ridicule and mockery by the end of this. There's another blunder. This is in fact not supposed to be like that. Yeah, it's supposed to attach to that. Unhide that. Attach the fourth one of that to is that right? I think that ought to be right. Oh, I'm missing something. I need to attach this to that. Any questions? Nah. Cool. And that should just be aligned. Okay, chassis done. Yippee. Is this is not. Alright, what's the distance? What is the distance between this and this? 27 inches. Alright, now everything's fixed up nicely. What? Oh. Work. Internet is acting quite funny. But nobody's laughing. Ta-da. Okay, now it's a little bit late to say this, but I made it upside down. Uh-oh. Can I transform this whole thing? Alright, it's upside down. Cool. We can unfix this part right here. What we'll do is rotate it 180. Just flip that over. Boom, look at that. I'm a genius. Now, if I go... Wow, what is this module doing? I don't think that's quite how that goes. I mean, hypothetically, that would fit right there. No, that would hypothetically not fit, actually. I lied. I'm a liar. I'm a backstabbing scoundrel. No, not quite. No. Oh, well, alright. I guess it works. It's not quite supposed to happen. Alright, anyway, chassis. Woo! To the chassis. Yippee. Anyway, any questions? No. Good. Any questions here? Anybody send me an email? What's this person want? Okay, chassis. Yippee! Alright. After an hour of mistakes and blunders, we have finally completed our nice little chassis. Now, with this, we now go into the cool tablet drawing part. Alright, so what we did last year was we had a plate right here. And a plate right here. We had a plate right here. And these were attached via hex shafts. And then we had a cool spinny thing right here. And the ball. Ball would go into here, right? And then there was a joint on the outside of this. It didn't go here. It went back here, but I'm drawing it like that anyway. And it would actually, it's probably better to draw it right here. There was a thing right here, and it would go in that, and then there would be a thing, and then it went like that again. Good. Ah, stop. Okay. And then that would be attached like there. There was wheels on that. And there was one right here, wheels on that. There was a hex shaft right here, and a hex shaft right here that would stick out somehow with geometry over that. The ball would go in there. It would fall into this belt. There was a belt right here. This I don't know if you can even pay attention to these scrambles. It would go right there, and then it would fire out. Anyway, cool. So we're gonna go ahead and design that. Actually, no, we're not, because there's like 10 minutes left. We don't have time. We'll continue this tomorrow. I'm gonna stay for like a minute and let people ask questions. Otherwise, I am gonna let everybody go and head out. Got a few things I need to do. Oh, written guide is the like binder written guide kind of thingamabobber is coming out pretty soon. Be dropping it in the Discord and a community post on here. No, I say pretty soon, but that could be anywhere between a week and a year. So I don't know. We'll see. Anyway, I'm gonna go ahead and let everybody go. Have a good one.